हाय फ्रेंड्स, वेलकम बैक। आज का टॉपिक है एसी ड्राइव्स। इसमें हम पहला देखेंगे स्टेटर वोल्टेज कंट्रोल, मेथड ऑफ इंडक्शन मोटर यूजिंग एसी वोल्टेज कंट्रोल। दूसरा स्टेटर फ्रीक्वेंसी कंट्रोल मेथड। तीसरा स्टैटिक रोटर रेजिस्टेंस कंट्रोल by using chopper. Fourth, slip power recovery. Slip power recovery method. Slip power recovery method में दो देखेंगे, स्टैटिक क्रैमर्स मेथड और स्कर्बियस मेथड। ओके, सबसे पहले देखते हैं स्टेटर वोल्टेज कंट्रोल। ऑफ इंडक्शन मोटर यूजिंग एसी वोल्टेज controllers. Okay, this is the first method. Three phases R, Y, B. Okay, this is three-phase supply, AC supply. Now connect track or anti-parallel SCR okay, so we choose anti-parallel SCR for high voltage and triac for low voltage. Now connect to the stator. This is rotor and connected load. Okay, if voltage here is Vs, voltage across this is kVs and k is less than or equal to 1. Okay, so at starting में क्या होगा, TD is greater than TL, developed torque is greater than load torque, so therefore speed increases. After reaching steady state TD is equal to TL. Okay, now see, there are four types of load generally. First is TL is constant. Second is TL is directly proportional to omega square. Third is TL is proportional to omega, and fourth load is this is constant power load. Okay, so we see which load is suitable for this method. Okay, let's check for TL is equal to constant. So consider machine is running at rated load and rated speed. Okay, so in this condition TD is equal to TL. So if we decrease the voltage, therefore TD is decreases, therefore TD is less than TL. If TD is less than TL, speed decreases means slip is increases, therefore current increases and current increases means TD increases. So here the machine will slow down and draws more current from supply in order to build up the torque TD until TD is equal to TL. Therefore, so for this type of load, machine is overheated. Machine is overheated. Okay. Now, second type of load, TL is directly proportional to omega square. KVS decreases, therefore TD decreases, therefore TL is less than TD is less than TL. Therefore क्या? Omega is decreases. Omega is decreases means slip is increases. Increases means slipping increases. But here this is not right, because omega decreases, TL also decreases. TL also decreases. Okay, TL is decreases and speed is decreases until TD is equal to TL is equal to TD. Okay, so this type of load is suitable for this method, because here current is not increases. Therefore, overheating of machine is not possible. Third one is TL is directly proportional to omega. So this and this method is same. Fourth is TL is inversely proportional to omega square. So here the reverse procedure will be there, because K omega S decreases, TD increases, TD greater less than TL, therefore omega R decreases. Omega R decreases, therefore tau L increases. ठीक है, tau L increases means current increases. So in this method, current increases, therefore overheating of winding will be there. Okay, so this type of method is suitable for TL is directly proportional to omega square and TL is directly proportional to omega. Stator frequency control. So in this method, first we see to control the speed less than omega. So in this method we have to go through V by F control, because NS is 120 F by P. So for decreasing NS we have to decrease frequency. For decreasing speed we have to decrease frequency, and Vs is directly proportional to phi NS. NS is directly proportional to F. So to maintain flux constant, if we decrease frequency we have to decrease Vs. Okay, so in this method V by F is constant to maintain constant flux. Okay, we can realize VF by control by using cycloconverter. Cycloconverter is used for which device? High power and low speed drives. Therefore, we can use this method by using cycloconverter up to 40% of rated speed. So in this, maximum speed is limited to 40% of rated speed. Also, we can use V by F control method in PWM inverter also. So in this case, the advantage is we can eliminate most of the lower order harmonics and increases the frequency of predominant harmonics. Okay, so this reduces what? This reduces the pulsating torque and machine runs smoothly. So this is the advantage of PWM inverter. We can do with cycloconverter also and PWM inverter as well. Now for omega greater than omega r. In this method, Ns is equal to 120 F by P. To increase speed, we have to increase frequency. So Vs in this case is maintained fixed and phi F is increases, so phi should be reduced. Okay. So as the frequency increases, flux and torque decreases. ठीक है, इसमें torque और flux decrease होगा. So in this method we can maintain constant power for all the speed above the rated speed. For above rated speed we can maintain constant power. Okay, because PD is what? Tau d omega. So omega is increases, tau d is decreases. So in this case we can maintain constant power. In this method we will use square wave inverter or PWM inverter. Okay, but in square wave inverter harmonics is more, therefore torque produced will be pulsating. So we generally use PWM inverter to reduce harmonics. Okay. Now third method is static rotor resistance control by using chopper. So in this light is a stator and this is a rotor. Here we supply three phase, this is R, Y, B. Here slip ring is connected and here a 6 pulse diode rectifier is connected. Okay, and a smoothing reactor will be there. Then a chopper, and here external resistance. Okay, so in this case let current here is ID and here IR. Okay, so total copper loss is what? इसकी वजह से 3IR स्क्वायर RR रोटर का जो रेजिस्टेंस है वो प्लस ID square 1 minus alpha RE. Here current will flow for 1 minus alpha time. Okay, IR is what? 2 by 3 ID. Okay, so ID is 3 by 2 IR. So total copper losses is SPG 3IR square RR प्लस यहाँ पर पुट करेंगे तो 3 by 2 IR square 1 minus alpha RE. So 3IR square यहाँ से कॉमन निकालते हैं, RR plus 1 minus alpha by 2 RE. So the effective resistance is what? This. Okay, but in this method power is wasted. power is wasted. Okay, so we will go through slip power recovery method to recover slip power. Okay, so next method is slip power recovery. Slip power recovery method. First of all, you will see Kramer's drive, static Kramer drive. Okay, in this induction machine, these three phases, and we supply in stator and from rotor a diode, 6 pulse diode rectifier, a smoothing reactor, and here a full wave converter in reverse polarity we connect. Okay, here LED voltage is VO1 and here VO2. Now from here we connect a transformer, 3-phase transformer, 3-phase transformer, and this will go to 3 phases like this. Okay, so this is the circuit diagram of Kramer's drive. So this diode rectifier can work in rectification mode only. Okay, rectification mode only, but this can be worked in rectification and inversion mode both. So from here AC supply will be there, so this diode convert AC to DC rectification mode, therefore VO1 is positive. Then DC, this is used for DC to AC conversion, this is inversion mode. So alpha is greater than 90 degree, therefore VO2 is negative. PD is equal to what? 1 minus SPG. So in this current is increases means slip is increases, slip is increases means PD is decreases, PD is decreases means speed is decreases. So this method is used for subsynchronous speed. So Kramer's device is used for subsynchronous speed only. Then second drive is Scherbius drive. Scherbius drive. In Scherbius drive, this is the 3 phases. The only one changes is in place of diode rectifier, we will use full wave 6 pulse converter. This is induction motor, this is the rotor, slip ring, and a full wave converter. Here voltage is VO1, a smoothing reactor, and in opposite polarity VO2 minus plus. Okay, like this, and from here transformer is connected. Okay, like this. So this is the Scherbius drive. The only change is here, in place of 6 pulse diode rectifier we will connect 6 pulse full wave converter. Here current is ID. Okay. For subsynchronous speed, we will use first converter as AC to DC and second converter as DC to AC. For supersynchronous speed, we will use first converter as DC to AC and this converter is AC to DC. Okay, so we can, in this method we can take power from this side also, from transformer side also, like this. Power will come like this. Okay, so in this method we will control the speed above rated speed or less than rated speed also. So subsynchronous can be achieved like Kramer's method. सुपर सिंक्रोनस के लिए यहाँ पर अल्फा 1 को फायरिंग एंगल 90 से ऊपर होगा और अल्फा 2 इसका जो फायरिंग एंगल है वो 90 से कम होगा. तो ये रेक्टिफिकेशन मोड पे काम करेगी और ये इन्वर्शन मोड पर काम करेगी. ओके, so in this way we will get super synchronous speed also. So this is all about AC drives. Thank you.